Hello, I'm Aden Morrison, and we're here to talk about how different situations affect metabolic pathways. And we're going to look at one situation for cellular respiration and one situation for photosynthesis. But we're going to start with a situation that affects cellular respiration, and that is cytomegalovirus. Now, this cytomegalovirus is an infection that causes dramatic alterations to intermediary metabolism. In affected cells, glucose carbon is not completely broken down by the tricarboxylic acid cycle, or the Krebs cycle as we learned it, for energy. And instead, this glucose that's not broken down is used biosynthetically. This process requires increased glucose uptake, increased glycolysis, and the diversion of glucose carbon in the form of citrate from the Krebs cycle for use in cytomegalovirus-induced fatty acid biosynthesis. Now, fatty acid synthesis is a creation of fatty acids from acetyl-CoA and NADPH through the action of enzymes called fatty acid synthases. This process takes place in the cytoplasm of the cell. Now, the effect of the cytomegalovirus infection on a host cell metabolism is increased glycolysis during the infection. Oxidative phosphorylation is also increased, and the electron transport chain functions at an elevated rate. So basically, everything speeds up in this cell. Now, this isn't always a bad thing, but can cause some negative problems. First, it could cause cancer. Now, an increased metabolism and energy production could make the cells rapidly reproduce and no longer function correctly. And these cells will take up a lot of energy because they're rapidly producing so fast. And this is exactly what cancer cells are. Cells that begin to uncontrollably reproduce themselves and no longer function and just take energy and keep spreading and spreading. So it would make sense that if a cell had increased glycolysis and was just making too much energy at an alarming rate, it could become cancerous. Another potential negative implication of cytomegalovirus increasing glycolysis in the cell would be if there's not enough oxygen to combine with pyruvate, and the pyruvate could start to build up. And if the pyruvate builds up, more of it will enter the lactic acid fermentation cycle, and more lactic acid will be produced and built up as a result. Now, we don't want lactic acid built up in us because in the name it says acid. It's toxic, so it could have a higher pH and mess with stuff right in the body because we all know that the proteins in our body need a specific pH to operate at. But also, if lactic acid build up, that could cause muscle fatigue because lactic acid is what makes your muscles feel tired after exercise. And so if it's building up just by your cells operating too fast, then you could start having muscle fatigue without even exercising. And we don't want this. As well, if the cell's glycolysis speeds up because of cytomegalovirus, you could lose weight because the metabolism is just going faster and energy is just being used at a faster rate. More ATP is being produced, but being used fast. Now, in the name cytomegalovirus, it is a virus, so it stays in the body forever. Except it is found that in almost all cases of people that have cytomegalovirus, it is not too worrisome. It only can have some of these negative implications, but more often than not, it's not that big of a deal. Now, mild cytomegalovirus is not usually treated because most times people don't even know they have it, and it will subside on its own. Now, if the infection threatens something more serious, if anything I listed happens, it could be treated by giving an antiviral drug. There are many drugs that could do this: valganciclovir, ganciclovir, cytofovir, foscarnet, or a combination could be given. So that is how cytomegalovirus infects the cellular respiration system and its metabolism, glycolysis, and the whole shebang. Let's move on to photosynthesis. So a factor that affects photosynthesis is temperature. Now, this is a big factor in photosynthesis because, most people, when they think of things that affect photosynthesis, they directly think of like things that are actually used, like your water, your glucose, your water, your energy, etc. Like cellular respiration and many other reactions, photosynthesis uses enzymes. Now, enzymes are proteins that have an optimal temperature that they work best at. And if the temperature is too low, these enzymes might not have enough energy to meet any substrate molecules. But if the temperature is too high, they can denature like other proteins because enzymes are proteins. So the temperature that a plant's in makes a big impact on how photosynthesis can occur. So at a low temperature, between 0 and 10 degrees Celsius, these enzymes that carry out photosynthesis might not work efficiently, and in such it'll decrease the photosynthetic rate. And if the photosynthetic rate is decreased, the plant won't get enough energy, it won't be making enough, and it could lead to a decrease in glucose production and will result in stunted growth of the plant, which is not good. Now at a medium temperature, between 60 or 70 degrees Fahrenheit, or around 30 degrees Celsius, photosynthetic enzymes work at their optimal levels, so photosynthesis rates gauge high. And at these optimal temperatures, the photosynthesis and energy produced is usually not the limiting factor. The limiting factor becomes the diffusion of carbon dioxide into the leaves. Now, if you go too hot above these temperatures, then the rate of photosynthesis could decrease again because enzymes do not work as efficiently at this temperature, because enzymes, proteins, have a specific temperature that they prefer, despite that this could mean increased carbon dioxide diffusion into the leaves. And if the temperature goes above 40, then these enzymes potentially could lose their shape and functionality, and photosynthetic rate could decline rapidly. So temperature is very important to the metabolic pathway. Now, enzymes are used all throughout the metabolic pathway, but there's a lot used in the Calvin cycle. And if these enzymes are not at their optimal temperature, and it's too cold for them to work or it's too hot and they denature, the Calvin cycle won't be able to go, and photosynthesis will not function as a result. Now, the organism itself cannot directly deal with this because plants can't move to their preferred temperature. But this could be why plants grow in certain areas of the world in certain climates and flourish, because those areas happen to be at the optimal climate. And that's why over time plants probably grow in the best temperature. Now, temperature has another effect on photosynthesis, and this is if the temperature is too hot again and it goes 40 degrees or higher, then the plant will close its stromata so the water doesn't evaporate. And this is when photorespiration happens. So if the plant closes its stromata and water doesn't evaporate, then CO2 can't get in because stromata is where the gases get in. And instead the plant builds up oxygen. Now, photorespiration happens because rubisco, an enzyme in the Calvin cycle, works with oxygen as well, but it is not optimal for the plant. So that's why this isn't good. So this is why plants in warmer environments over time have learned to work differently so they can deal with the heat. So there's different types of plants essentially in warmer environments so they can still operate. Now the different types of plants are called C4 plants and CAM pathway plants. Now a C4 plant has a physical separation between the Calvin cycle and gases, so it delivers CO2 to the Calvin cycle. It uses ATP, but it is worth it in the end, so this plant can still function in its environment. Now the CAM cycle is a temporal cycle because it opens the stomata at night so it can take in a bunch of CO2 when it's not hot enough to dissolve the water, but it remains closed during the day so it can operate and its water doesn't evaporate. That's what I know about metabolic processes